So the solutions to that is introduction of dead zone in the rotor, introduction of tooth notching, using sinusoidal magnetization, and then also using the technique on your stator. So here are some examples here. So you have the rotor here, and then you have your two notch edges cancel SC1A. This is your interaction here with the rotor and stator, and you have two notches here. You basically are increasing your cogging frequency. You are artificially adding more stators without fundamentally altering your electromagnetic architecture. All right, so torque ripple, now normally torque ripple happens anytime your back EMF does not match with your back EMF or the current waveform doesn't perfectly match with your back EMF. Whenever, so the torque ripple essentially is the direct cause of a mismatch between your back EMF and the current injected into the motor winding. Okay, so of course there can be other causes which lead to distortion of back EMF. For example, your magnets not being magnetized properly, or your discontinuities in your stator or rotor can also lead to non-sinusoidal back EMFs. So in order to improve the back EMF, you can have skewing, fractional sock winding give you pretty good waveforms, short pitch winding, increased number of phases, air gap winding. So these are some of the ways to improve the back EMF so that you can have a sinusoidal excitation of your motor. In terms of improved control techniques, modified PWM control techniques, DC bus voltage control, current control based techniques, direct torque control, and phase. Now, this is mainly, I would say, related to BLDC, where you have trapezoidal control, where you can improve the trapezoidal control by using some of these techniques. Okay. So let's look at short circuit conditions at motor terminals, what happens and how can we detect them. And then we also look at internal, external power supply voltages and over temperature failure conditions that we need to have in the drive as a standard protection mechanism. Okay. So we're looking at a short circuit to ground, short circuit to battery, short circuit to line, weak short circuit in the microcontroller, Hall problem, and then MOSFET issues, right? Those are some of the issues we're going to discuss here.